Risk Assessment Teach 1 presentation. This presentation was prepared as part of HAP 725, Statistical Process Improvement, taught by Farrokh Alemi, PhD at George Mason University, Department of Health Administration and Policy. Sherita Edwards is a Master's of Science in Health Informatics student at George Mason University. The purpose of this assignment is to calculate the likelihood ratios associated with each diagnosis in predicting above or below average length of stay. Likelihood ratio is the probability that an event will occur in a patient with a specific disease compared to the probability that the same event will occur in a patient without a specific disease. I have completed this question in both SQL and Excel. So we'll start first with how to complete this question number 2 from week 3 in Excel. First, after you open up your data, you are going to change your diagnosis data into binary data for each diagnosis. As you can see in column H, I created an MI column. Column I created a CHF column. Column J, I created a diabetes column. In column K, I created an alcohol abuse column. In column H, cell 2, I typed in a if statement to change all of my MI data to binary data. And in this dialog box, I typed equal if, and cell B2, which corresponds to MI data, if B2 is equal to MI, then there's going to be a 1 placed in the cell. If not, there would be a 0. And you're going to do this for the entire column of H. And then you're going to do the same thing for your CHF, diabetes, and alcohol abuse. Next, we're going to calculate the weighted average length of stay for each diagnosis in Excel. And as you can see, I came down to the bottom of my worksheet and I typed in weighted average, and in this highlighted cell beside weighted average, I went up to the dialog box and I typed in the formula that will give us our weighted average, and that was equal sum product column F, which contains all of our length of stay data, multiplied by the information in column G, which is our number of patients, and we're going to divide all that by, again, our number of patients, which is column G, and that will give us our weighted average. After we have calculated our weighted average length of stay, we're then going to create a column for above average length of stay, and in the first cell, or in cell 2 of that column, we're going to put a formula with an if statement that will calculate a binary number for above average length of stay. So the formula will read equals if, and we're going to use F2, which is our length of stay. And for that first case in column F, and if that is greater than our weighted average, which is 3.24, that column will get a number 1. If not, it's going to get a 0, and you're going to do that for the entire column. Now we're going to calculate our prevalence in above average. So you're going to go to column N and create a column for prevalence and above average length of stay, and then column O, you're going to have prevalence and below average length of stay. And you're going to go over to column M and you're going to put your diagnosis in those cells that you see here. And in the highlighted cell that you see in column N, cell 2, what you're seeing there is the result from this formula in the dialog box here, and that is equal sum product of our length of stay, which is, not length of stay, our above average length of stay, which is in column L, and you multiply that times the binary MI data in row 8 in column H, and also by our number of patients in column G, and that gives you the prevalence and above average length of stay. You're going to do that for each diagnosis. Next, you're going to go to column O, cell 2, and calculate the prevalence of below average stay for MI. And this formula is nearly exactly the same as our prevalence and above average, except we're going to put a 1 minus in front of the MI data. And we're going to do that for each diagnosis, putting a 1 minus in front of the data for CHF, diabetes, and alcohol abuse. And that will give you your prevalence and below average for each diagnosis. Finally, you're going to be able now to calculate your likelihood ratio for each diagnosis. You're going to go over to column P, create a likelihood ratio column, and as you can see in cell 2, in P2, you use the formula where you divide the prevalence and above average by the prevalence and below average, and that will give you your likelihood ratio. And in the case of MI, in this Excel example, it is 4. The likelihood ratio for CHF is 1.31. For diabetes is 2, and alcohol abuse is 4. Again, this is the final product after you've completed all of your likelihood ratios for each diagnosis. Now I'm going to show you how to answer the same question in SQL. It's a little bit different, but some of this is slightly familiar. After you have imported your data into your Excel file into SQL, you are going to change your diagnosis data into binary data like we did in SQL. This is the code snippet for doing that, and I created a file mmindex1, and this is the printout or a picture of what the product is when I ran that code. Next, you're going to calculate the average length of stay in SQL. This is the code snippet that you use to calculate the average length of stay. And as you can see, it's the same as our calculated average length of stay and the calculated length of stay, average length of stay in Excel example. This is an example of the code snippet you're going to use to find the prevalence of above average length of stay, designated here as MI and long, and our below average length of stay, designated here as not MI and long. You're going to use the same snippet of code for all your diagnoses. Where you see MI, you're going to change it to either CHF, DM, or AA, and you're going to create another temporary file. I use count 1, count 2, count 3, count 4. This is the code snippet I use to calculate my likelihood ratio for MI. You will see in the other Teach One assignments that there's another code used. I decided to use this one because it most closely resembled what we did in Excel, and it gives you the exact same value, and it's a shorter snippet. So you can repeat this code, and for everywhere that you have MI, you change it to CHF or alcohol, AA, or DM for diabetes, and that will give you your corresponding likelihood ratios for those diagnoses. This is the finished product of all those calculations that I copied into SQL. These values are slightly different from the numbers that we calculated in Excel, but I just wanted to show you how you could do it in either Excel or SQL. Thank you for listening to my presentation.